Hi, in this video we are going to work on inverse functions. First, let's talk about the characteristics of inverse functions. Now let's look at this function. This is f of x equals x squared minus 3, x being all the real numbers but the positive ones and 0. And the graph of this is something like this. The y-intercept is negative 3, and just because it is x is greater than or equal to 0, it's only 1/2 of the parabola. Now, we know the domain, which is given here. X is bigger than or equal to 0, so that's the positive r values, and 0. What is the range? So let's write the domain is x is greater than or equal to 0, and the range is, well, the minimum point is -3, so it goes up. So we can consider the y values to be greater than -3. So I will write y as a real number. Y is greater than or equal to -3. Instead of y, you could write f of x. That's equally the same. Now, certainly the questions will ask us to find the expression for the inverse function, and let's work on this quickly. Well, if you remember from IGCSE, you were to start with this equation and then swap the unknowns. So it's going to be x equals y squared minus 3, and then you leave y alone. Whatever you find on the other side will be the expression for the inverse function. So if you work this out, it's going to be x plus 3 equals y squared, and then you take the square root of both sides, and you end up with y equals square root of x plus 3. Now, just a warning here. If we were to work on, let's say, a squared equals 9, and when we take the square root of both sides, we were to write a equals plus minus 3. There should be two values coming out of the square root, because we don't know whether it's -3 or 3. The reason is that when you take the square of 3, you get 9, but when you get the square of -3, you also get 9. So when you're taking the square, you know the information, whether it's negative or positive, but when you're taking the square root, you don't know. So you have to consider both options, plus and minus. Whereas, when we are dealing with functions here, by default, we assume that this expression here is positive. So we don't go like plus minus. Because the problem is here that when you try to sketch the graph of something like this, for example, you end up with something like this. This is a sketch of y equals square root of x plus 3, okay? And this is exactly the reflection of this graph about the x-axis, right? And this is y equals minus square root of x plus 3. But by default, we consider this as our inverse function, and we cannot consider them both, because then it's not going to be a function at all, okay? So we just go with the positive value. So long story short, my inverse function will be f inverse of x, that's how I read and write, is equal to square root of x plus 3. That's my expression for the inverse function. How about the graph? Well, the graph will be something like this. So this is f inverse of x, and this is f of x. And just because it's a sketch drawn by hand, you may not sense it, but actually these two graphs are the reflection of one another about the y equals x line. So this is the mirror line, and they intersect for this particular function. They intersect here. They are not always intersecting, but they intersect here. But they always reflect about the line y equals x. So this is the mirror line. Now I'm going to write the domain and range of the inverse of the function. Well, we don't need to spend too much time on this, because what happens is, if the domain of f is this, and this is the range, and the function is defined like that, the inverse function will be defined the other way around. So the domain of the inverse function will be this, and the range will be this. So they just swap. Meaning, I'm going to write here for the range of the inverse function, f inverse, and here the domain of f inverse. Of course, the letters must change. This must be y, this must be x, if I'm writing the domain and the range of the inverse function. So I'm going to just copy paste all these expressions here, but I'm just going to change domain and the range and the letters, that's it. And of course the letters here as well. So basically, it is going to be like this. Notice that this is the same as this, and this is the same as this, just the letters are different. Finding the expression for the inverse function is important, and there are a few different sorts of functions, so I'm going to show you how you can work these out quickly. Right, let's start with these functions. F of x is 3 over x minus 1. We'll try to find the expression for the inverse. So first I write y equals 3 over x minus 1, then I write x equals 3 over y minus 1. Obviously I have to go with cross multiplication, like this, and then it's going to be xy minus x equals 3, and then take x to the other side, saying xy equals 3 plus x, and then dividing by x, I'm going to end up with the expression 3 plus x or x plus 3, it doesn't matter, over x. So that is my inverse function. F inverse of x equals x plus 3 over x. For the second one, I start with y equals square root of x minus 2, and then swap the letters. X equals square root of y minus 2. Well, the only thing I can do is to take the squares first, so it's going to be x squared equals y minus 2, and then add 2 to both sides, or take 2 to the other side, ending up with y equals x squared plus 2. So that is the inverse of this function. Now, just an addition here. If the question would be like square root of x minus 2 outside, for example, plus 5, right, it would look like this. Certainly, before taking the square of both sides, I have to get rid of this. So I would first end up with, let me go on here, x minus 5 equals square root of y minus 2, and then take the square of both sides. So it's going to be x minus 5 squared equals y minus 2, and so on. Careful with that. If there is an additional subtraction here outside the square root, then you have to take it to the other side first, and then take the square of both sides. Now let's look at this one. Here I'm going to start writing with y equals e to the x minus 3, and swap the letters. X equals e to the y minus 3. Now from last year, we have to remember that logarithmic functions and exponentials are inverse to each other. So after writing x plus 3 equals e to the power of y, I am going to take the ln of both sides. Now at this point, let me remind you, ln stands for logarithme naturel, like French, all right? So this is natural logarithm, where the base is the exponential number, all right? So just because the base is exponential number, ln e means 1, right? So basically, I'll go like ln x plus 3 equals y times ln e, which is 1. So y equals ln x plus 3. That is the inverse function here, ln x plus 3. Now, what if we have the function to be ln? Now let's look at this example. I have g of x equals ln in brackets x plus 2. So first I write y equals ln x plus 2 and then swap the letters. X equals ln y plus 2. Now at this point I have to know this rule, which is e to the power of ln f of x, a function here like y plus 2, is equal to the function itself. That's because exponential and natural logarithm are inverse to each other, right? So next step will be that I'm going to write the left hand side and right hand side as a power of e. So it's going to be like e to the power of x is equal to e to the power of natural logarithm y plus 2. At this point, I'm going to use the rule and say e to the x equals y plus 2, because these sort of cancel each other out because they are inverse to each other, right? And after that, it's easy to leave y alone. It's going to be y equals e to the power of x minus 2, and that's my inverse function. Now is your turn. Please solve these questions on your book and submit your answers online. Please note that you have to submit only part B of each question. Thanks for watching.